and we had two other side lengths. Let's say 8 and 15. Right? When you look at the information that's provided to you and you kind of sketch it out, if the given side that's opposite the given angle is the larger of the two, there's only going to be one solution. Okay? So if the side that's opposite the given angle is longer than the other side, then there's only one solution. Okay? And when I show you the case with two solutions, I'll explain it in more detail. But this is the rule. If you remember this or have it written down somewhere, okay, and can refer to it, it'll save you or allow you to find that information out. Okay? So if you're given a pattern of SSA, meaning two sides and the non-included angle, okay, as long as the side that's given that's opposite the given angle is the larger of the two sides, then you are only going to have one possible solution. Okay, so in solving this, in this particular case, we would be looking for angle B, angle C, and side B. So this is a case where finding the angle is not the easiest way to start. Or it's not as simple as it was for the ASA and AAS patterns. And we are still going to find an angle, but it just won't be as simple. Okay, but we can determine our known ratios, right? Our known ratios are the what? The A's, the B's, or the C's. Here's our known ratio, the A's. Okay, and so what we can do is, which of the angle measures can we actually find here? B or C? So we only know one other piece of information, the 8. The 8 is related to which of the angles? C. So we're going to start with our unknown in the top. So our unknown is the angle. So I write my equation as the sine of C over the side opposite it, A. Notice it got flipped from what we were doing for the other two forms. And that's equal to my known ratio. Again, because I have my angle on top, I'm going to take the sine of 25 degrees over the known side 15. Okay, so here is the law of sines for this SSA pattern. Right now, your calculators can't calculate, they can't solve for the unknown embedded within a trig ratio. And some of you have tried that already on different things. And you can't use the solve feature to do that. So in this particular case, you need to follow one of these two kind of steps. Either manually set up the calculation, so multiply both sides by 8 to get your variable alone. And you can calculate the sine of C is equal to, and we find what that calculation is. So sine of 25 divided, or times 8 divided by 15. And so I get my sine ratio to equal 0.225. And if I know that that's my sine ratio, then I know I can calculate angle C by doing what? We did it in the last section. If you know the sine of C is this ratio, to calculate the angle C, you take the inverse sine of that ratio, and that's going to be your solution. So if I take the inverse sine of this ratio I just calculated, I get my angle measure for C to be 13.0. Okay, once I find my first angle, now what's the next piece of information I can solve for? Angle B, using the triangle sum, take 180 degrees, subtract the two angles that you just measured, so 25 and 13.0, and I get my angle B to be 141, or actually 142.0 if I'm rounding. All right, once I find that angle measure, my last piece of information is side B. So I can set up my trig ratio, B over the sine of the angle opposite it, 142. And that's equal to my known ratio, which, because I started with side B, I'm going to put the 15 on the top, the side on the top, the angle on the bottom. So I'm using this same trig ratio, I'm only flipping it now. Okay, and so in this particular case, I can use the solve feature. Solve for, I'm going to replace the B with an X over the sine of 142. Make sure you use the exact numbers. Okay, don't round your numbers, otherwise you'll be off enough to where it will take points away. Set that equal to 15 divided by the sine of 25, comma x. It'll solve for this unknown. And when I do, I get my measure to be 28.9 approximately. Is that consistent with what I would expect? My longest side is opposite my largest angle. My smallest side is opposite my smallest angle. The sum of the two smaller sides so I got 21.9. The sum of my two smaller sides, 8 and 15, is 23, which is greater than 21.9, my longest side. So everything is consistent that I was expecting to see here. All right, now, I had mentioned that in this particular equation right here, you cannot use your calculator in the form of solve sine x over 8 equals sine 25 over 15. It won't calculate that for you. It is possible to use your calculator, though, so let me show you how that would work if you were solving this. And what you would basically do is you'd let x represent the entire trig ratio, not just the variable, but the whole thing. And so if you kind of let this whole thing be represented by x, you could then use the solve feature, and you could say solve x over 8 equals sine of 25 over 15, solve for x. Now, when I calculate this, what it's not calculating the angle c, it's calculating the sine of c. So once I find what that is, if I basically just add it to my equation right here, and get 0.225, I can now solve this resulting equation the same way I did right here, right? It winds up being exactly what I had right here. And so if I just take the inverse sine of that ratio and solve it, I'd get my measure. Okay? So you can still use the solve feature, but if you do, you have to let x be the entire trig ratio and then solve for it, and then you manually take the inverse of that trig ratio.